Hello everyone, my name is Nikita and I am from the Bodhi Academy. In the previous video, we had started with the chapter Light from 10th Standard Science, and we had seen what are the different types of mirrors, what are spherical mirrors, and some of the quantities and some of the measurements which we need to know about the spherical mirrors. Okay, which is in terms of reflection part of light. Now today we will be moving on further and we will be studying the next concepts of the same lesson. Okay, so today we'll be saying what something called as principal focus. Okay, the principal focus. So first we will be seeing the principal focus of the concave mirror, and next we will be studying the principal focus of the convex mirror. So talking about the concave mirror, okay, we know that the reflecting surface of the concave mirror is the inner surface of the spherical mirror. For example, if this is the mirror, the reflecting surface is the inner part. Okay, the inner part is the reflecting surface and the outer part is the plane surface. Okay, the plane surface. Now we had already studied some measurements about the mirror. The center of the mirror is called as the pole. Okay, now the center of the whole sphere becomes the center of curvature of the spherical mirror, and it is given by letter C. And the distance between these two, CP, is called as the radius of curvature. Okay, so today we will be seeing one more quantity about with respect to this mirror, that is the principal focus. Okay, for this we need to do an experiment. Okay, in the experiment it is said that the light rays, okay, the light rays which falling on the light rays which goes. Now I had mentioned that this is the principal axis. This is the principal axis. Okay, so the first thing which we need to know about is the light ray goes parallel to the principal axis. The light ray in this case goes parallel to the principal axis. Okay, so if this is the light ray, this is the incident light ray which is parallel to the principal axis. It is going in this direction, so I have to show the arrow in this way. Okay, the arrows are very important. So this is one light ray, so such many light rays go parallel to the principal axis and fall on the concave mirror. The light rays go parallel to the principal axis and fall on the concave mirror. They are incident. Now what happens after the light ray is incident on any mirror? It gets reflected, right? And that's how we have image formation. This I discussed last time. So in this case also, the light rays going parallel to the principal axis reflect. Okay, all reflect means they reflect. And what happens after reflection? They reflect and they meet at a single point. Okay, so if this ray is coming this way, so I will put the arrow this side. Okay, and in this case the arrow will be this side. Okay, so the light rays after going parallel to the principal axis, falling on the concave mirror, it comes and meets at a single point. Okay, it meets at the single point. This have to be straight lines, and now this becomes a concentrated point, the point at which all the light rays meet. This single point becomes the point at which all the light rays are meeting. It is the intersecting point for all the light rays, and this point is called as the principal focus of the concave mirror. Okay, the light rays. So how do you define the principal focus of the concave mirror? The light rays going parallel to the principal axis. After reflection, all the light rays come and meet at a single point on the principal axis. This point is called as the principal focus of the concave mirror. Okay, so this is how we define the principal focus of the concave mirror. Now we will see what is the principal focus of the convex mirror. Okay, so for principal focus of the convex mirror, we will draw the mirror this way because the reflecting surface is the outer part. Okay, now from the light ray is coming from, in this case the light ray is coming from an object which is placed very far away. So object is always present on the left hand side. So no matter how the mirror, so we need to change the position of the mirror accordingly so that the object is always on the left side. So for this reason we have placed the mirror this way, because the object has to be this way and the reflecting surface have to be this way. Okay, so the convex mirror will be placed this way. This is the reflecting surface of the convex mirror. The outer surface becomes the reflecting surface. Okay, and the inner one is the plane surface. Okay, so again we will be drawing a principal axis which passes through the pole of the mirror. Okay, and in this case now the reflecting surface, now in this case the center of curvature is this way. Okay, the center of curvature is on the other side of the mirror. Okay, so you have to remember that in case of a convex mirror, the center of curvature is placed on the other side of the mirror, not in front of the mirror. Okay, now same thing we have to do here, the same principle. So what happens in this, the light rays parallel to the principal axis. Okay, all the light rays go parallel to the principal axis. Okay, all the light rays go parallel to the principal axis. So the arrow will be this side. Now here they intersect at one point. Okay, they converge. Okay, they come closer, all the light rays come closer and converge. So here in this concave mirror, no, we use the word converge. Okay, they converge and meet at one point. Okay, now but in this case after reflection, after being incident on the mirror, after reflection they appear to diverge. Okay, they appear to diverge, means they are not converging, they are diverging. Diverging means like going away. Okay, but the angle of divergence, they are diverging from a point which is present on the principal axis. Okay, they are diverging from a single point. Okay, over here they are converging and meeting at a single point, and over in this case they are diverging from a single point. Okay, and so we have to show that point in dashed line. Okay, and this point is called as the principal focus of the convex mirror. Okay, convex mirror. Now, so what is the difference in both the mirrors? First of all, the reflecting surface of the concave mirror is the inner part. Okay, and reflecting surface of the convex mirror is the outer part. Now what happens to the principal focus? Okay, the light rays after being incident on the concave mirror, they converge and meet at a single point. But in case of convex mirror, the light rays being incident on the convex mirror, they diverge from a single point on the principal axis. Now the principal focus is, in case of concave mirror, it is lying in front of the mirror, and the principal focus and center of curvature also, in case of convex mirror, it is lying behind the mirror. So we say that concave mirror, okay, we say that the concave mirror is a converging mirror, converging, and convex mirror is diverging mirror. So these are the main differences with respect to mirrors. Now with respect to both the spherical mirrors. Okay, Now pay attention to CP. Okay, C and P. We have said that this CP on the principal axis, the distance is called as the radius of curvature. Okay, which is given by letter R. Okay, now you have noticed that between this CP we have found another quantity, which is the focal length, which is the principal focus. Okay, the principal focus. Okay, over here also, no, it should come in between, exactly in between. Okay, so it's like principal focus lies midway between the radius of curvature. Okay, it lies midway, means it divides the radius of curvature into two parts. Okay, and the distance between the principal focus and the pole, okay, this distance, or over here you can say this distance is called as the focal length. Okay, focal length means which is given by small f. Okay, principal focus is given by f, and the distance between the principal focus and the pole of the mirror is given by the small letter focal length. Okay, so I have said that the focus lies midway between the between the radius of curvature. So it is focal length. The focal length is half the radius of curvature. Okay, so we say that R is equals to 2f, or focal length is equals to R by 2. Okay, so over here it is evident that the focal length is half of the radius of curvature, and radius of curvature is twice the focal length. So if a problem is asked wherein they say that the radius of curvature, okay, R of a mirror is 8 centimeter, what will be its focal length? Okay, focal length. So how do you do this? You have to use the formula R equals to 2f. Okay, 2f, wherein R is 8, this is 2f, and then you get f is equals to 8 upon 2, which is equals to 4 centimeter. So if focal length is 4 centimeter, the radius of curvature becomes 8 centimeter. So focal length is half of the radius of curvature. Okay, so today we have seen what are the principal focus of the concave and convex mirror, and these are the basics. These basics are very, very important, which will help us to study the further parts. For example, mainly the ray diagrams. Okay, the most important part of this chapter is the principal focus and the ray diagrams. The principal focus of both the concave and the convex mirrors are the most asked questions, like frequently asked questions in the Goa board exams. Goa board exams means either the concave or the convex mirror can be asked. So we need to be thorough about the rays, the arrows, diverging, converging, all these terms, we need to be thorough about them. Okay, so this is all about the focus and the formula. In the next video we will be seeing the various rays, rays which are used for drawing the ray diagrams. Okay, it's like the formulas which are used to draw. Actually they are the ray diagrams which are used for various image formations. Okay, when the image is found at various when the image is formed when the object is kept at various distances. So that we will see in the next video. Okay, so thank you for watching my video. Please like, share and subscribe to our channel.